Okay, so we are talking about problem solving with C++ by Savitch. And right now we want to go to section 2 of chapter 2. So we are talking about chapter 2. We're going to be talking about section 2 of chapter 2, which is input and output. And that's what we're going to be talking about it in this lecture. So we can think about the data coming into our program and going out of our program. So if you remember in chapter 1, you had a picture like this, that you had your CPU communicating with the main memory. Remember, CPU can only see main memory. That's what it's called, main. And then the secondary memory, hard drive or anything in that matter, is outside of these. And then you have your So you have your input and you have your output. One way of looking at this, for me, to make it more understandable, I would look at it as a manufacturing. So I would look at a manufacturing. So for the manufacturing, you would have a raw data coming in, and then we would do some kind of a processing, and the finished product is going to go out. So we can think about our program that's going to need some raw data, and we're going to do some processing for it. And then we're going to have our finished product, which is our data that goes out. So I want to mention the data because we're going to have two types of the output, and I want to focus on the data. So we're talking about input, processing, output. So that's IPO. So the input can come in from the keyboard or the file. We're going to get to the file in chapter 6. And the output is going to be, the standard output is our screen. So we're going to put things on the screen, or we can write it to the file. Again, chapter 6, we're going to get into that area. So IPO that I'll be talking to you for the design part is when I want to write a program. Before I want to start a program, I want to know what kind of data do I need to process, what is the processing that I do, and what is the outgoing stuff, outgoing data. So that's input, processing, output. So we are going to be using a cout to print stuff to the screen. Now we're talking about two different things. In manufacturing, let's say the manufacturing is creating clothing. We can think about it as a picture of the clothing, that you can just take a picture of the clothing, or we can talk about the actual clothes that we can go buy it and use it. So here we have two types of things that we can do with the CI. One is, first of all, this is called insertion operator. So we can print stuff to the screen without even knowing what it is. So if I put it inside a double quote, well, I'm going to get back to \n, but if I put something in double quote, the operating system is not going to even look at it. Just going to take that one and just going to display it in the screen, just like a picture type of thing. Of course, the only thing that's going to do, if it sees a \, then it knows some special things is happening over there. So it's going to do something about it. So if I don't have a \n, it's just going to take it, display. If I have a / something, it's going to do something about it. We're going to get to that. The other one is the actual data. So if I have a cout and I put a variable here, that's going to take the content of that variable and it's going to display it in the screen. So we're talking about data, the value of the data. We're going to talk more about the \n. So two things I want to bring up over here. One thing is I have a space over here. Why do you think if I have a space? If I don't put a space over here and I put the number of bars, it's just going to stick with the candy. So let's say I have 25 bars, there's going to be 25 candy next to each other. So it's going to be something like this. It's going to be 25 candy bars, which looks kind of ugly and not user-friendly. So we're going to talk more and more about user-friendly. But if I put a space between them, it's going to be much easier to read. And that's what we are talking about over here. To put a space over here to make it more user-friendly. So we are doing the value of number of bars, and then we're going to print this one right after. And we are using insertion operator. So we can put cout in different lines, or we can put them in the same line. I'm going to go over different formats of the using cout for you as a programmer. I strongly believe each programmer has his or her way of writing program, and I can guarantee if I have 90 students, each one of them going to write differently. After a while, when you're doing the peer reviews and you're getting used to these things, and we're doing a little more complicated program, you can tell very easily whose program is this, if you have seen it before. Everybody has their own style, just like art. So you're going to see it, I'm going to see it. And if somebody's copying it from somewhere else, it's very, very obvious that, and you're going to see. So what I'm saying is everybody has their own style of doing things, and we're gonna look at different styles. So my goal is to give you different options, give you the convention, and then you choose how you want to do it. And when you go to industry, you go to a company, they have their own convention, and they usually adopt a general convention, and they add a little bit here and there to make it the way they want to do it for any reason that they have. And that's what I'm talking about, putting the cout in multiple lines, in one line. We're going to talk a little more about it. So the key over here is the coded strings are enclosed in double quote. Single quote is for just one character. We are not going to use that right now. So it has to be double quote, and that's what we're going to be using. If I want to do a blank space, that would be the blank space for me. So different formats of doing the same cout. I can put a cout at each line, starting a cout. And if I do that, I have to end it with a semicolon. So if I decide to put multiple cout in multiple lines, then I need a semicolon for each one of them. I can put, more than one in one line, and I just put the insertion operator, and then I separate them like that. Again, it's going to need only one semicolon for one cout. So I could do it this way, or I could do it this way. Take the candy bars, put it in the top, having two lines with two in each one. Another one that is one of my favorite ones that I like to do is, I am a lazy typist, so I find ways to type less. So I'm going to put a cout. I'm going to put this in multiple lines, just one cout, multiple lines. I'm putting these insertion operators, but I don't have any semicolon. So the semicolon is right here. I'm lining this up, so it's just going to be easier to see it. And then the last one would have a semicolon. So all these three ways, or maybe different ways, are the same thing. So you choose the way you're comfortable with, and you do it that way. Okay, so If I want to use a C in, C out, I need to bring some modules to my program. So pound include is bringing some module to my program, and that is the IO stream, input output stream, that's coming into my program. And we're going to be using namespace std, that is a directive that's used for the IO stream. If I don't have this using namespace std, then I have to type std : cin, std : cout. So for two reasons, we are not going to do it. One is because your book has this style and we're going to follow this book. So all your programs are going to be in line with what we have in the book. And two, for me, is less typing. So instead of having std, I just do using namespace. I don't have to type it anymore. All right, let's get back to the backslash. So as I said, when we are working with cout, we have two ways of doing it. One is to put it in a double quote. So you would have a double quote with nothing in it. So it's going to take whatever content you have in double quote and just put it in. Now, the only thing it's going to do is going to look for backslash. If it sees backslash, it says, okay, there is a special thing going on. So as soon as it sees a backslash, it says, okay, something is going on. So it's going to look at the next character after backslash, and it's going to figure out what is that special thing about this. So in this case, if it sees an N, it's going to give me a new line. It carries you to. It's going to go to the next line. And that backslash N, or any kind of a backslash, doesn't have to be all the way at the end all the time. It can be at the beginning, it can be in the middle, it can be anywhere. You can have one of them, you can have 5 of them. There's no rule that you have to have it always at the end. Now, the compiler is going to come in, it's going to look at the backslash, it says, okay, something is special about this. If it's an N, it's going to give me a new line. If it sees a T, it's going to give me a tab. So it's going to tab. And remember, the tabs are different in computers. Computer to computer tabs are different, but it's going to give me that. Now, what about if I want to put a double quote? Remember, if I put a double quote right here, if I put a double quote over here, let's say I want to put bars inside the double quote. If I put a double quote here, it thinks that it's the end of this one. It's going to get confused with that. So what we're going to do is we're going to put a backslash, and then we put a double quote after it. So when it sees the backslash, it says, okay, it's a special character after this. When it sees a double quote, then it's going to print the double quote for me. So if I want to do this, and I want to put bars to display as double quote, I'm going to do it this way. Cout, and then I'm going to say candy. Now I want to have bars in double quote. So I'm going to have backslash, double quote, bars. Now I want to put another double quote for bars. And then I have another double quote for closing it. So this, the last one is closing this one. So this whole thing is one string. That means because here, when it sees the backslash, it's going to print this double quote before bars, and this one is going to print the double quote after bars. So that's the way I'm going to be displaying candy bars in double quote. Now, then the question is going to come and say, what about if I just want to print backslash n or a backslash? So that is going to be for this one right here. If I do double, that means it's not a special anymore. It's just going to be that character. So cout backslash n inside double quote is going to give me a new line. but cout backslash n is going to print what? You might want to try it out, see what happens when you do this. Okay, so that's for that one. Now, one more thing that we have to do is when we have things in double, the decimal point, the precision of it is not always the same. Meaning that if I print something in double, it can print like 78.5, or it can print at 78.500000, or it can print 7.85000 E01. E09 is the same as 10 to the power of 1. So that means this is 78.5. So E is a scientific notation, just like a math, you have 10 to the power of something. This is, we're going to be using E. So it's barely going to show me 78.50. Now we got to figure out a way to do this. And I am with you. This is not my favorite thing to do. And I think that C++ should have taken care of this a while back. But we have 3 things that we have to take care of. So first thing first, we have to do, we're going to be using this iOS because these things are not, they don't belong to our namespace std. These are std namespace iOS. So we're going to be using a colon. First thing first, we want to change our numbers from scientific notation to fixed notation. So the default in C++ is scientific notation. So if I don't do anything, it's going to show me in scientific notation. So 50,000 can be shown as 5.0 E04. So same thing as 5.0 times 10 to the power of 4. So first thing, we're going to change it to fixed, so we don't want to show it in scientific notation. Next, I want to show the point. So meaning that even if it doesn't have a decimal point, I want to show the decimal point. So 50,000 doesn't have no decimal point, but I want to show it with a decimal point. So 50,000 becomes 50,000.0. And the last thing that I want to do is I want to do the precision to 2. So now my 5 becomes 5.00. We're doing all these things. So we have to do this. It's just a lot of work for some of us, but we're just going to put it in there. I'm going to use it. And that's the way we're going to be formatting. When we are reading stuff, we are going to read through cin. Cin is going to bring it to our variables. It's going to take it. Right now, standard input is our keyboard. So it's going to take it from the keyboard and it's going to put it in the variables that we're going to define. This is called extraction operator. That's going to extract things and it's going to put it in there. Now, in this case, we are reading 2 numbers. We are asking the user to put 2 numbers. The key with the cin is that cin skips not the cin itself, the extraction operator is going to skip over spaces, tabs, and new line. These are called white spaces. So if I have 2 numbers that I want to read, it's going to be sitting here and waiting for the user to put 2 numbers. Now the user is going to put 2 numbers. They can put it next to each other with a space. So it's going to read this one. It's going to wait over here. Then the next read is going to skip over this space and it's going to read the next one. I could potentially put it in 2 lines. So it's asking for two numbers. I could put 1, enter, 2, the number, enter. I could put 1 and put a lot of spaces, a lot of lines, and then put the other ones. That's fine also. It's going to skip over new lines. It's going to skip over spaces, and it's going to put it in the variables. So just like cout, just like the other things that we were talking about, we have different ways of doing the cin. And as you learn things, you're going to get more comfortable of doing these things. So let's go over the data first. So I'm asking the user put 3 numbers. The user can put 3 numbers with the space between them and push enter, or remember the cin extraction operator is going to skip over spaces, so they can put it this way, or the user can put it in all 3 of them in different lines. They can put 2 of them in one line, third one in different lines, put 2 of them in different lines and put one way on the other side. It doesn't really matter how the user puts. It's going to read 3 numbers. So different ways of doing the cin, just like your cout. You can put all of them in one line, separated with the extraction operator and 1 semicolon. So we have 1 semicolon for 1 cin. I could put the cin, my way of doing it, without the semicolon, 1 semicolon, 1 cin, or I can put them in different lines. So these are different ways of doing cin with 3 inputs. So when we are asking a user for something, if I don't display any kind of text, and my program is going to run, it's going to flash, and the user has to put something in. The user doesn't know what I'm expecting them to put in. So we're going to make our screen a little more friendly. So we're going to add some text, like enter age, so the user know the number that's going to be putting is going to be age. And when we displaying that, we want to have some kind of a verbiage that what is this? So if I display 25 on the screen versus I display 25 was entered, or I would say 25 age was entered, then we know exactly what we're talking about. So adding some extra text to make it easier to do the input and do it easier for doing output. So the user is important. We're going to make our program user friendly. That's something that's going to be in our mind all the time. So this is activity 2.2. I want you to be ready to discuss these things in class. And that's going to end our session for chapter 2, section 2.